Welcome again to our Maths and Physics class. We are continuing with dimensions of physical quantities. In our last videos, we were able to explain the use of the three fundamental quantities, mass, length, and time, and how we're going to use the first letters to represent them in these dimensioning processes. Today, we are going to be dealing with acceleration, and probably we'll take one other for quantity to add to it. Now let us look at acceleration. Like I told you, the first step you are supposed to take is to write the formula of the physical quantity. From what we know, acceleration is equal to velocity over time. From acceleration equal to velocity all over time, and when we remember what we discussed in our last videos when we discussed about velocity and dimension it, we have already established that velocity, the dimension of velocity is what? Length times time raised to the power minus 1. That is dimensioning we had in our last class. Now, instead of us dimensioning velocity, there is no need for us to dimension velocity again. What we just do is to lift that we have already concluded from our last class. What we do is to represent velocity with it. L t raised to the power minus 1 all over time. We are not dimensioning time because time is a fundamental quantity. Time is a fundamental quantity, so it is not dimensioned. So we now have L t raised to the power minus 1 all over t. If you look at our various videos that we dropped weeks back, even up to the last videos, those sets treated laws of indices, and the essence of those videos was because of these dimensions of physical quantities. It was to put in us the knowledge of how we can manipulate this type of fractions, this type of expressions. This expression that we have here is L t raised to the power minus 1 all over t. Remember, we have t and t, both numerator and denominator. And we have said that when you have two quantities that are the same, dividing each other, what you do is to pick one of the quantities, pick one, then minus or subtract the powers or the index or indices. So what do we now have there? We now have A, or acceleration, is equals to L t raised to the power minus 1. Since we have picked one of the t's, the power that is coming with this one is t raised to the power 1. It will now become minus 1. Remember, here is 1 raised to the power 1. This is L t raised to the power minus 1. T is just 1 here, so it is the same thing as saying t raised to the power 1. Now this is the L. Since t and t are dividing each other, we pick 1. Minus 1 is already there. What do we do to the other power? We also say minus. We subtract it from the one that is already existing as numerator. So let us now simplify this. L t minus 1 will give us minus 2. So this one shows that the dimension of acceleration is equal to L t raised to the power minus 2. So in other words, I can as well express this one as what? L all over t raised to the power 2. Because t raised to the power minus 2 is now acting or multiplying the numerator. If I take it to the denominator, it will change in sign. The power will change in sign. Instead of negative 2, it becomes positive 2. So that is the essence of dimensioning. So how does this one relate to the SI unit of acceleration? Now remember, I can write this L as what is length. So the SI unit for length is what? Meter. I want to now construct the SI unit of acceleration from the dimension of acceleration. The SI unit of length is what? Meter. The SI unit of time is what? Seconds. That would be seconds squared. So if I want to write that one in another form without using the division sign or division line, I can write it as what? Meter second raised to the power minus 2. You can as well write this one as what? Meter slash second square. This slash is just the division line or the division sign between the numerator and the denominator. That is why you have the SI unit of acceleration as meter per second square, or simply meter second raised to the power minus 2. So that is how you get the dimensioning or the dimension of acceleration, and from the dimension of acceleration you can generate the SI units of acceleration based on the fact that you know the dimension. Now, the essence of dimension of physical quantity is for people, probably you have forgotten the SI unit of a quantity, or you do not know at all the SI unit of a quantity. But if you are very good in dimension of physical quantity, you can generate the SI unit and know the SI unit of a quantity without necessarily knowing it before. But if you are familiar with dimensioning and you are able to bring in the symbols or the letters that are representing the three most important fundamental quantities, you will be able to get the dimension of any physical quantities, and then you will generate the SI unit of such a quantity. We will end that here. We are going to rub the board, then we will bring in the next one, which is force. So we are going to see now the dimensioning of force. So how do we dimension force? How do we dimension force? Like I said, we're still going to take the first step. We write the formula. Force is equal to mass times acceleration. Now, mass is a fundamental quantity. We do not dimension that. We write mass as a fundamental quantity times acceleration. Acceleration, we have just discovered or come up with the dimension of acceleration as what? What did we say is acceleration? We said acceleration is equal to what? L(t) raised to the power minus 2. So what I need now to represent or replace this acceleration is to just say L(t) raised to the power minus 2. So that is that. Remember, force is equal to mass times acceleration. Mass is a fundamental quantity. I will just represent it with m, big letter M. From our first video, you will know the reason why we are putting M here, because it represents mass as the first letter. We are using capital letter M. Then acceleration, we have dimensioned it to have L(t) raised to the power minus 2 from our previous this class, from our previous video we just did. Then that one will tell us that we have L(t) raised to the power minus 2. So let us multiply them and simplify the expression. It will now become L(t) raised to the power minus 2. So let us from here generate the SI units. We do not know the SI unit of force. Okay, what is the SI unit of force? It will be mass. What is the SI unit for mass? Kilogram. What is the SI unit for length? Meter. What is the SI unit for time? Second. Remember, it is t raised to the power minus 2. It will become second raised to the power minus 2. So this now becomes the SI unit of what? Of force. But in most cases, we do not see these units written after we calculate force. So what we see is, we say 5. Force is equal to 5. For instance, say 5 newton after calculating or being given in questions. F of force is equal to 5 newton. F is equal to 2.7 newton. So how does this relate to this? Just note this, that the main unit, the main SI unit for force is kilogram meter per second square. But because of the man that discovered a lot concerning force, that man's name is Isaac Newton. So it was arranged or suggested that his name should be used as the unit of force. So that is why you see that the SI unit of force is Newton. But this is the main SI unit as in dimensioning of the physical quantity force. But because of the contribution of this man as a Newton in discovery of so much concerning force, his name is now used as the SI unit for force. That is why, or hence, when you calculate force or you are giving force, you see the unit which is represented with the capital letter N written after the value. So that is where we'll end this class today. Remember, before you dimension any quantity, write the formula first. Once you are able to write the formulas, bring in each of the quantity one after the other. The one you have dimensioned before, if it is part of the formula, there is no need for you to start dimensioning it again, like acceleration here. We have dimensioned it. What we do is to bring the result of that dimension, which is L2, Lt raised to the power minus 2. And from there, you apply the indices or law of indices, you will get all the answers that you are looking for. Thank you very much for watching. Please like this video, comment, follow us on our Facebook page, our YouTube, our TikTok. Then please do not forget to share these videos for others to benefit and for you as well to get videos whenever we upload them firsthand. Thanks for watching.